Hello everyone and welcome to .NET Core Central. In today's video, I'm going to discuss about MassTransit and how to use MassTransit with ASP.NET Core. Before we start getting into the code, let's first discuss what is MassTransit. MassTransit is an open source framework for building distributed applications in .NET. And the key features of MassTransit are: number one, it has an out-of-box integration available for RabbitMQ, ActiveMQ, Azure Service Bus, and Amazon SQS as well as SNS. It supports message patterns such as event-driven state machines, sagas, message consumers, as well as distributed transactions. Now we will go into each of these features in today's as well as subsequent videos because there is a lot of grounds to cover here and it will not be possible to cover everything in a single video. So in today's video, I'm just going to cover the message consumer and how we can use the message consumer pattern for communicating across multiple microservices using MassTransit through RabbitMQ. And in the subsequent video, I'm going to talk about distributed transaction and sagas. And then the next important feature it supports is in-memory test harness, which makes it very easy to implement unit as well as integration test. And the other key feature it supports is advanced monitoring, such as distributed tracing and service health checks. First, let's start with building a ASP.NET Core application using MassTransit. Now, I'm going to take two-step approach for building the application. First, I'll build a ASP.NET Core application where I am not going to use the extension methods that are provided by MassTransit. Instead, I'm just going to use the basic service bus and the factory to show how the internal works, because when we get and start using extension methods, this all will be hidden. I think it is important to understand the basic APIs, and then I'm going to use the masstransit.asp.net NuGet package and use the dependency injection extension methods to use MassTransit. So first, let's start by creating a new ASP.NET Core web application, and I'm going to name this application as order service. This is a service which ultimately will be responsible for sending order through RabbitMQ. On the other side, there will be inventory service which will be listening to the message and update the inventory based on the order. First, let's create the order service. I'm going to select API and ASP.NET Core 3.1. Just go ahead and create this. Once the project is created, I'm going to add the NuGet package for MassTransit. And as I mentioned earlier, initially I'm not going to use the masstransit.asp.net core NuGet package. I'm just going to go with the MassTransit base NuGet package. And of course, I will also have to install the MassTransit.RabbitMQ NuGet package. So after I install the MassTransit, I'm going to install the MassTransit.RabbitMQ NuGet package. This is the NuGet package we will need for accessing RabbitMQ. As I mentioned, initially I'll just go ahead and create a base implementation. In the configure method of the startup, after all the configuration is done, I'm going to use the bare bone implementation of MassTransit because, as I mentioned, I'm not going to use the extension method initially. And for the RabbitMQ, I'm going to use the existing RabbitMQ that I installed in one of my previous video. And if you have not watched the video, I'm going to share the link in the description. I encourage you watch that because there I showed how I installed it using a Docker. It's very easy and straightforward to do that. So currently it has only the default exchange and queues are all empty. I'm going to go back to the order service and now I'm going to create the bus control provided by MassTransit. So for that, I'm going to declare a variable called bus equal to bus.factory.create using RabbitMQ. So here I am saying that I want to create a bus using RabbitMQ as my broker. And here I'm going to pass the config. Inside of the config, the first thing we are going to do is we are going to declare the host for the RabbitMQ. So here I'm going to pass the URL of the RabbitMQ that I have installed. So that's the URL. And then after the host is configured, what I'm going to do is I'm just going to declare a listener. So I'm going to say config dot receive endpoint, and the first parameter of the listener is the queue name. So I'm going to create a temporary queue. And then next is again action, and for this action I'm going to pass C, and here what I can do is I can do handle, and for handle I have to pass a message, what kind of message I want to handle. And as you can see, it's a properly defined type, and this type is very critical, and I'm going to explain why. Once we run this application, it will be very clear. For the time being, I'm just going to go ahead and create a new class. And it is also important that this model that we are going to use is available in a shared library. And I'm going to explain why that as well. And it will be clear when we go through running this application why it has to be a shared library. So I'm just going to name it as model. And for this class, I'm going to name it as order. Next, I'm going to add this model as a dependency to this project, and then I'll go back to the startup. I'll use order here, and then after we get that, we'll get a context which is going to be returned when a message is received from the RabbitMQ. This particular lambda expects a return type of task, so we can do return console.out.writeLine async, and here we're going to do context dot message, which is going to give us order dot name, and I'm going to create a property called name in the order class. So here we created the bus, we created the host associated to the bus, and created a receive endpoint, which is the handler which will be triggered when a message is received in this queue. Now what I'm going to do is I'm going to start the bus. So I can do bus.start. Ideally we should be using start async, but since this is inside of the configure method for just for the demonstration, I'm not going to use start async. And again, this is not the code we are going to use. We are going to use the extension method where everything is implemented properly. This is just to get through the basic and understand how the message and the queue plays an important role and how it all tied up in RabbitMQ by MassTransit. So we're going to do start, and then here itself we can do bus.publish, and we can publish a message. And for the message I'm going to again use new order name is equal to test name, and that's about it. I'm not going to stop the bus, so I'm going to run this application now. When I run this application, I can see the test name showing up here. And now if I go back to the RabbitMQ, I'll see that there is a new exchange created with the name of temp.queue. There's a new queue created with the name of temp-queue, and you can see the consumer is connected to this and it got a message. And apart from the temp-queue, you can see that model colon order is another exchange created, and both of them are fan out exchanges. And model colon order is basically derived, the name is derived from the type that I have given. And if we go into the temp-queue, we can see that the model.order exchange is sending message to this exchange, and then it is going to the temp-queue queue. So as you can understand, the significance of this is that whatever object we use for handling or for publishing, that becomes the top level exchange, and that exchange then routes message into the exchange, which is the default exchange created for the queue when we use the handle. So here essentially what is happening is temp-queue exchange and temp-queue queues both are created and they are attached to each other, and then based on order, the model.order exchange is getting created, and anything which is coming from message.order will be routed to temp-queue exchange. And that binding is happening here because during the publish we are not specifying any exchange or anything, we are just specifying what object it has to go. So when we do that, it will default get into the RabbitMQ, figure out is there an exchange with the model.order. If not, it will create one, it will publish the message there. So on the other side, if no one is listening to this order, the message will go into ether. So that's how it works. Now I'm going to get rid of all this code. As you can see, why model is so important, this order object, and why it has to be outside? Because it has to be used by both receiver as well as publisher. So it makes sense keeping it as a separate model, and we should ideally be creating a NuGet package out of it and using the NuGet package in both publisher as well as receiver. Now let me get rid of this code because we are not going to use it, and now I'm going to make this order service as a publisher alone, but I need to add couple of namespaces before I do that. So the first namespace I'm going to add is MassTransit.extension.dependency injection, and the second namespace that I'm going to use is MassTransit.ASP.NET Core. Once both these namespaces are installed, what I'm going to do is I'm going to go into the configure services method, and here I'm going to say services dot add MassTransit, and then I'm going to take the config action, and here I'm going to configure the MassTransit, and just like before I can do config dot use RabbitMQ, and this time I'm going to get an action which has a context and a config, and here we can say config dot host, and we are going to pass the URL of the host for the RabbitMQ just as before. And after that, what we are going to do is we are going to say services dot add MassTransit hosted service. Now as you can see, it adds a MassTransit I hosted service which includes a bus and endpoint health check. Once we add this MassTransit hosted service, it takes care of creating the bus and managing it. We don't have to do anything. So these are the only couple of lines of code we need to configure MassTransit with the RabbitMQ, and that's about it. And next what we'll do is we'll create an order controller, and we're going to create an API read-write controller, and we're going to name it as order controller. And here I'm going to create a constructor. In the constructor, what we can do is we can use I publish endpoint interface from MassTransit, which is going to help us publishing a message into the RabbitMQ. And on post, I can use order object here, and I can do publish endpoint dot publish order, and here I can say order. That's about it. And instead of I can use async task of action result, and here I can do an await and then return okay. I'm not doing any exception handling right now, but we should be using a try catch block and handle the exception appropriately. So this will publish a message to the order exchange, but right now it just has the exchange. We have not done any other thing. I'm just going to get rid of all these exchanges so that we can start fresh. And this queue as well. Okay, so we are back to the beginning. So now this controller will be used for publishing a message. Next, what I'll do is I'll create the subscriber controller. So for the subscriber controller, I'm going to create a new ASP.NET Core application. And as I mentioned earlier, this will be an inventory service. And I'm going to create an API just like the other one. And once the project is created, I'm going to go ahead and add all the necessary NuGet packages for MassTransit. So I'm going to install the MassTransit, and then I'm going to go ahead and install MassTransit.RabbitMQ, and then the MassTransit.extension.dependency injection, which is necessary for configuring the DI. And then finally I'm going to go ahead and install MassTransit.ASP.NET Core. So once all these three are installed, I'm going to pretty much copy paste the code from the previous service, but I'm going to make some changes here. So this part of the code will remain the same. Just going to add the necessary namespaces. Now use RabbitMQ part and configuring host part is going to remain same. But remember, just like the last time, we have to create the receive endpoint here. So we'll do config dot receive endpoint, and for the receive endpoint we are going to provide a name of the queue, and this time we are going to probably provide a better name. So let's say order queue, and then just like before we'll take the lambda, but this time we are not going to use an inline method because the goal is not to do all the logic here, right? We are going to create a class which does this, and this is where the consumer pattern comes into play. So we can do configuration dot configure consumer, and we can provide the consumer that we want to handle this message, and we are going to name it as order consumer, and then we're going to pass the context that is available at the top level. I'm just going to create this order consumer in a new file, and the other thing we have to do is up top we have to say config dot add consumer, because we have to register the consumer order consumer. Now we are getting red squiggly because it does not implement the interface, so it has to implement the interface iConsumer, and we need the order model. So for the time being I'm just going to add the existing project for the model, but as I mentioned earlier, this should be done through NuGet package. Let me add a project reference for the model, and let me use order here. And let's implement the interface, and as you can see the interface comes with a single method. And now here I can do the same thing. I can say console.out.writeLine async, and I can take the context dot message dot name. That's all I'm going to use, and I can use an async here. So this should do. Now our startup is all configured. So here what we have done is, apart from configuring the RabbitMQ, we have added a consumer, and then we configured the consumer when we attached an endpoint. So now what is going to happen is it's going to create an order queue exchange and an order queue message, and then it will create the model.order exchange, which will be connected to the order-queue exchange, and the message will flow through that pattern. So now if I run this application, let me change the port number, otherwise both of them will be competing for the same port. Okay, and now let me run this application. Now one thing to keep in mind is the consumer is added as scoped by the MassTransit. So if we are using any dependency inside of the consumer, we should also be using scoped, unless we really want it to be a singleton. And now if we go back to the RabbitMQ, we can see that the model.order fanout exchange is created, which is sending message to the order queue exchange, and order queue exchange is sending the message to the order queue. So this is how the whole pipeline is created. We are going to run the order service, and now we are going to open up Postman, where we are going to make a post request, and I have set the content type as application/JSON, and in the body we can pass the name, hello MassTransit. Let's open up the inventory service here, and now if we send a message, we should see the inventory service got the message hello MassTransit, and it is working as expected. Now one thing we can do here is in the inventory service we can introduce a dependency in the order consumer just to show that the dependency injection will work as expected. And the easiest dependency to add is going to be the iLogger, because I don't have to create any class or anything. So we can just create a logger, define the logger, and here we can say logger / log information. And at this point, if we want, we can get rid of the control.writeLine, but I'm just going to keep it so that it's easier that way. Otherwise we have to return a task.completed task. So I'm just going to keep it as is, and I'm going to run, and this time we should see the console write line as well as the logging message. If I go here, just say hello MassTransit again, send a message, and come here, we can see got new message, hello MassTransit again, and before that we got the hello MassTransit again, which is the console.writeLine. So it is working as expected. So this will give you a basic understanding of how we can use MassTransit for communicating through RabbitMQ across multiple microservices using a consumer pattern. And as you can see, it is very straightforward. The key to understand that the mapping of the exchanges is that whatever model you are going to use, that is the base level fan out exchange which will be created, which will be pumping the message into the other exchange that you are expecting it to be. So it is critical that the object or the namespace at least is shared across both consumer and producer. And that's the key. So that is all I wanted to cover today. In my next video, I'll try to cover some of the advanced topic like saga and distributed transaction. If you like this video, please give me a thumbs up. And if you are new to my channel and if you think you are getting value out of my channel, please subscribe to my channel. Thanks so much for watching this video.